All right, hi everybody. Now we're going to learn something else with logarithms. So today we're going to learn 3 different properties that can be applied when you're trying to eventually solve logarithmic equations. So we've kind of already gone over the basics, where if you have a single log, you rewrite it, or if you have a log with the same base on both sides, they would cancel out. So now you're going to see problems that will have multiple logs, in which you're going to have to apply properties. Now, if you take a look, each property has its own name. Do I care that you know the name? Absolutely not. All I care is the fact that you know how to apply it. Very similar to exponential properties. So, for example, if you take a look, if you're given a log with a base and you have some sort of product or multiplication happening on the inside, it can be what's called expanded by changing multiplication to addition. But when you change it to addition, you change them into 2 separate logs. So it'd be log base b of m plus log base b of n. Very similar to exponential properties. When you multiply, you add the exponents. So when you multiply, you add the logs. So same thing with division. When we divide it with exponents, we subtract. So therefore, we're going to do the same thing with the logs. Log base b of m minus log base b of n. This is the only one that's slightly different, and that is if you have some sort of an exponent on the inside, what's going to end up happening is that it's going to come to the outside and become in front of the log. So then this will turn into n times the log base b of m. So now what we're going to practice is we're going to practice doing what's called expanding and condensing. So going from here to here is called expanding because you have multiple logs. Going the opposite direction, when you go from here to here, it's what's called condensing. Okay, so we want to practice both things. So you're going to see some examples. Some are more complicated than others, so just make sure you take your time. After that, we're then going to do some solving equations using the properties. All right, so what we're going to do first is we're going to do expansion. So that's when you're going to take the log expression and you are going to expand it into multiple logs. So if you take a look at the first one, we have log of 12x to the third power. So this is kind of understood to where there's parentheses here. Now, the first common mistake people want to do is they want to take that 3 and bring it to the outside. But unfortunately, that is not the right first step. The reason is because that 3 is attached to the x. It has nothing to do with that 12. So what we end up having to do first is we have to separate the 12 away from the x cubed. Since they are being multiplied, and the rule that we have to separate multiplication, we are going to write it into addition. Now I can apply another property by taking that exponent and bringing it to the front of just the log that has the x. So my final answer would be log of 12 plus 3 log of x. Eventually, you're not going to have to write this in-between step. You may be able to go right from problem straight to answer, which is ultimately your goal. But some people need to write those in-between steps. So we're going to do that for a few of them. Okay, so second example, now we have division. Division gets separated by subtraction. So my first step would look like this. Minus log base 3 of x squared. Again, as you get practice, you're most likely going to bring that exponent in front immediately, which would make it log base 3 of 4 minus 2 log base 3 of x. So those are basic problems. As you can see in C and D, we get a little bit more complex. Okay, so there's multiple steps involved here. So again, we have division, which is what I'm going to separate first. So log base 7 of 3x squared minus log base 7 of 5y cubed. Now it's kind of like we have 2 problems like letter A in 2 pieces. So I need to separate the 3 from the x squared and the 5 from the y cubed. I'm also going to bring out that exponent at the same time. Okay, so I'm going to take care of that exponent all at the same time, just so we can do it all in one step. So I'm going to write log base 7 of 3 plus 2 log base 7 of x minus log base 7 of 5 plus 3 log base 7 of y. Now, there's one thing that I am missing for my final answer here. Since I am subtracting this whole log, I am going to need to put that whole piece in parentheses. So it kind of separates it away from the numerator from the denominator. Now, you can also, if you wanted to, distribute that minus through. But if you just leave it in parentheses, that's good enough as well. But just know you can do either way. But then that would be your final answer. So now let's take a look at the last example. So the last example, you'll see there's a square root in the problem. You've learned many times the square root is the same as something else. So all I'm going to do is I'm going to rewrite this. Log base 5 of x cubed y to the 1/2 power. Now I'm going to separate, and I'm going to bring those exponents in front, and I'm going to do this one all at once. So my answer is going to be log base 5, backtrack. My answer is going to be 3 log base 5 of x plus 1/2 log base 5 of y. And that would be the final answer. So now we're going to try some examples where you're going to condense and go the other way. Some people find that to be a little bit easier. It's a little bit faster. It's more visual. So again, we just went over expanding, where you're doing multiple logs, and now we're going to go to condensing, where it comes down to be one single log. All right, so this is condensing. So now you're going to kind of work in the opposite order. So the other problems, the last thing we did was bring the exponent to the outside. So now kind of your first step is going to be to bring the exponent to the inside. So if you take a look at letter A, I am going to take that 5 and I'm going to bring it in. That would be my first step. Log base 7 of 4 plus log base 7 of x to the 5th power. I am going to undo the addition by changing it into a single log and change it to multiplication. So then this would be your final answer as one single log. So again, a lot of people find this to be a little bit easier. It's a little bit more visual. But again, your answer should come down to one single log only. So now let's take a look at B. I am taking this log and I am subtracting this log. Subtraction turns into division. So it becomes log base 3 of x plus 2 divided by 5. If you would like to put the parentheses around it, you can. Even in example A, you can do that as well. Sometimes most people will do that just for emphasis, so you can tell that that's what you're taking the log of. All right, so now C. C, we've got a lot of things going on here. So C, you can tell right away that I have this being subtracted from this. So that can tell right away this piece is my numerator, this piece is my denominator. But what I'm going to do first is I'm going to bring that exponent in first to both pieces. So I'm going to do this side first. So it is log base 10, because it's a common log, so log of 3 plus log of x squared, which will then turn into log of 3x squared. Then I'm going to do the second piece, log of x minus 3 to the 3rd power. You do not have to FOIL that, just leave it as is. Drop down the minus sign, which then I'm going to change it into one big fraction, which then your final answer would be log of 3x squared over x minus 3 cubed. Again, you do not have to simplify anything. Leave it just as is. That's good. All right, last example. Again, bring that outside exponent in. Now we have something to the 1/3 power. So this is log base 2 of y to the 6th plus log base 2 of x to the 1/3. I'm going to do two things here. Addition is going to change to multiplication, and I'm also going to rewrite this piece. X to the 1/3 is the same thing as the cube root. So I'm going to change this to be log base 2 of y to the 6th cube root of x. So again, when you condense, you should only have one single log in the final answer. A lot of people make mistakes with the fractions because they want to put a log on top and bottom. But again, you're doing one single log. The base follows suit all the way through, so just make sure you're careful with that. The next lesson, which we're going to do next time, is apply these properties to be able to solve our last type of equation involving logarithms. So I want you to practice this first to kind of give you a little bit of an easier night. So I hope all is well. If you have questions, just ask. Again, look on Google Classroom, email me. Trying to take it one piece at a time. So next time we're going to be solving more equations. All right, so have a good afternoon, and I will see you next time.